Alright, hello honors chemistry students. Today we're going to be taking a look at section 3 in chapter 11, which talks about limiting reagents. Hopefully you've already read about this to help answer some of the questions from the stoichiometry activity that was due today. So limiting reagents, if you've noticed in most of the homework questions you've done so far in this chapter, it usually gives you an amount for one of the reactants and says that it reacts with excess or extra or unlimited amount of another reactant. And in most cases, in most chemical reaction, there is one reactant that we have a lot of extra or excess of and one reactant we don't. So when those two reactants combine to form the products, the one that we don't have excess of is going to run out first. And as soon as we are all out of one of the reactants, we can't make any more products. So that causes the reaction to stop. So the reactant that runs out first is referred to as the limiting reagent or limiting reactant. I think the book uses reactant. Either one is fine. But that's the reactant that runs out before the other reactant. And again, like I said earlier, as soon as we don't have one reactant, as soon as one reactant is all used up, we can't make any more products. So the reaction then stops. So it limits how much product we make, and that's why it's called the limiting reagent or limiting reactant. And so that's the chemical that is used to determine how much product will be made. As opposed to the other reactant that you've seen again in your homework assignments saying excess this or excess that. The other reactant then is referred to as the excess reagent, and that's the reactant that we still have some of that left once the reaction stops. So that's our leftover or excess reagent. Now there can be certain circumstances where both reactants actually run out at the exact same time. That can happen, but it's very rare. So most of the time you will have one reactant that runs out and limits how much product it's made because it stops the reaction, and you'll still have some of the other reactant left over. So what's different about these problems and the problems that you've done before is that you're going to be having two givens. So in all the other stoichiometry problems we've done up to this point, you had an amount, whether it's in grams, particles, or liters of one reactant, and then it said you had excess of the other reactant. But now in limiting reagent problems, you are going to have amounts, could be grams, liters, particles, but both reactants will have an amount. And you're going to have to determine which one is the limiting reagent, because that's the one that will make the correct amount of product. If you use the other one, the one that's the excess reagent, your answer for the amount of product made will be too large and therefore incorrect, because it can't happen because the other reactant would have run out. So there's a number of ways you can do this. I don't really recall what the book shows, and I've taught it several different ways over the years. But regardless of how you determine which one's the limiting reagent, which one's the excess reagent, you have to convert both of your givens to not only like units, but like substances. It's kind of like the saying of can't compare apples to oranges. So we have to convert the apples to oranges. So we have to have both the same type of units and the same substances. And again, there's different ways you can do that, but as long as in the end to figure out which one is your limiting and which one is your excess reagent, you're comparing like units of like substances, then you can figure it out. So again, you're going to have two givens, and you have to decide which one is used to determine which one to use to determine the correct amount of product. That's the one that's going to make the least amount of product. And so again, you have to convert both givens to not only like units, but like substances. You can just convert each given to moles of one substance. It could be the product, could be the other reactant. And that's fine. I've taught it that way before. before, but as you'll see in the example on the next page, I actually just like going to whatever unit and product we're solving for. So that's the preferred way for me. But regardless of how you do it, whichever reactant makes the smaller, if you just want to do moles, that's fine, or if you want to convert all the way to grams of product or liters or particles, whichever reactant makes the smaller amount of product is our limiting reagent, and whichever reactant makes the larger amount is our excess reagent. And the answer that is the smaller amount, whether again you converted it to moles or converted it to grams or not meters, but grams or liters or particles, that smaller amount is the correct answer, and that's the answer you would use to solve the problem, because that represents how much can really be made. Okay, so let's see how this works with actual numbers. So here we have a problem where it's asking us to solve for how many grams of aluminum sulfide can form from the reaction of 9 grams of aluminum with 8 grams of sulfur. So that's what's different about this problem than the problems we've done before. Normally it would just give you one given, like say 9 grams of aluminum, and then just say with excess sulfur, or vice versa, 8 grams of sulfur and excess aluminum. So because it's giving you amounts for each of the reactants, we have to determine, is aluminum our limiting reagent or is our sulfur the limiting reagent? Only one of them is, and that's the one that's going to produce the correct answer. But with all stoichiometry problems, you still need to come up with a balanced reaction, because we're still going to find which one is the limiting reagent by doing stoichiometry. So we need our balancing to give us our mole ratios. So I'm going to just do 2 stoichiometry problems with one for each of my reactants. And I'm going to go ahead and convert them all the way to grams of product, since that's what we're solving for anyway. And whichever one makes the smallest amount of aluminum sulfide, that is my limiting reagent. Again, you could convert both reactants to moles of product. You could convert one reactant to grams of the other reactant, or moles, as long as, again, you're comparing apples to apples as opposed to apples to oranges. Okay, so first I'm going to take the 9 grams of aluminum and convert it again all the way to our grams of product, aluminum sulfide. And just like we've been doing throughout this chapter, since I have grams here, I'm dividing by aluminum's molar mass. And then here's my mole ratio from my balancing. So since I'm doing aluminum and aluminum sulfide, I have the 1 mole of aluminum over 2 moles of 1 mole of aluminum sulfide over 2 moles of aluminum. And then again, I could stop there if I wanted, but we're solving for grams of aluminum sulfide anyway, so I'm going to keep going and multiply by aluminum sulfide's molar mass, which is 150.3. So after doing all that math, that if the aluminum is the limiting reagent, that tells us that the reaction will make 25.1 grams of aluminum sulfide. That may be the correct amount, but we won't know till we try the sulfur and see how much product the sulfur makes. So now we're going to do the same thing with the sulfur, starting with the 8 grams of sulfur. And so again, since we're in grams, we're going to divide by sulfur's molar mass, and then do the mole ratio between the aluminum sulfide and the sulfur. So we have 1 mole of aluminum sulfide over 3 moles of sulfur. And then again, I'm carrying it all the way out to grams of product, so multiply by aluminum sulfide's molar mass. And as you can see, the sulfur is only going to produce 12.5 grams of product. So what that tells us then is that the sulfur is our limiting reagent, because it makes the smaller amount of product. And so our correct answer for how much product the aluminum we can make from this reaction, the correct answer is 12.5 grams. So on your homework, tests, quizzes, whatever, when you're doing a limiting reagent problem, make sure you circle which one of these answers is the correct answer. Without that, I don't know whether you recognize that this is actually the correct answer. We cannot make 25.1 grams of aluminum sulfide because once we make 12.5 grams, the sulfur's gone. There's no more sulfur left. So this is the correct answer. So we would circle that. Let me go ahead and do that. So this is that's our correct answer. Okay. Now you may be thinking, well, that's super easy because obviously 8 grams is smaller than 9 grams. That may be so, but that doesn't indicate that that's going to be our limiting reagent. You can't just look at 8 smaller than 9, so 8 must be our limiting reagent. Because again, you're comparing apples to oranges. These are both in grams, but they're grams of sulfur and grams of aluminum, which each of these have different molar masses, and in this case they also have different mole ratios with the aluminum sulfide. So both of those things have to be taken into account, their mole ratios and their molar masses, and that's why you have to convert both things to not only like units but also like substances. And again, you could have stopped at moles if you wanted, but since we're solving for grams anyway, I just do the extra step and go all the way to grams, and then I've already got my answer. Now, besides just figuring out what our limiting reagent is and how much product it will make, we can also determine how much excess reagent will remain. So if the sulfur is our limiting reagent, and again, only reactants can be limiting reagents. So a lot of people start listing products as limiting or excess reagents. Reagents is another name for reactant. So sulfur is our limiting reagent. That must mean then that our aluminum is our excess. That's supposed to be an E. Excess reagent. And what that means is we have leftover aluminum. So when this reaction is finished, there's still some aluminum remaining. And we can actually calculate how much aluminum will remain. And to do that, we need to first subtract the amount of product made by converting back to our, so we subtract the amount of product made and then convert that back to whatever we started with in terms of our excess reagent. In this case, it will be grams. So we're gonna, up here, we have 25.1 grams of aluminum sulfide that the aluminum could have made, compared to 12.5 grams of aluminum sulfide that really was made. So we're gonna subtract those two amounts. There we go. So subtracting those two amounts, that tells us that if we didn't run out of sulfur, we could have made 12.6 more grams of aluminum sulfide. And then we're going to take that extra amount of grams of aluminum sulfide and convert it back to what we started with originally for our excess reagent, and that is grams of aluminum. So you'll always go back to the units and the substance of our excess reagent when you're doing that. So we just basically flip-flop this entire stoichiometry problem that we did up here, starting with 12.6 grams of aluminum sulfide. So that will look like that. So we take the extra amount, the 12.6 grams of aluminum sulfide, and now this is where labeling really helps out. We're in grams of aluminum sulfide. We're trying to get back to just grams of aluminum. So we would divide by aluminum sulfide's molar mass. So we put the 150.3 in the denominator. And then our mole ratio. Now the aluminum sulfide is our given, and we're solving for aluminum. So we put 2 moles of aluminum on top, 1 mole of aluminum sulfide on the bottom. And then to get us back to grams, like what we started with up at the top, we start with grams of aluminum. We need to multiply by aluminum's molar mass. So then after we do all that math, we find out that when this reaction is complete, we will end up with 4.5 grams of aluminum still in our beaker. So we made 12.5 grams of product. We don't have any more sulfur because that's all gone. That's what stopped the reaction from continuing, but we'll still have 4.5 grams of aluminum remaining. Now we can show how, like we've been saying since the beginning of the year, we cannot create or destroy matter. We have to obey the law of conservation of matter. So we can actually show how all of this obeys the law of conservation of matter by comparing the amount of matter we had at the beginning of the reaction versus the amount of matter we had at the end of the reaction. So before the reaction started, we had 9 grams of aluminum, 8 grams of sulfur, and no product, for a total mass of 17 grams. And then after the reaction, we had 4.5 grams of aluminum remaining, no sulfur because that was our limiting reagent, it was completely gone, and then we made 12.5 grams of aluminum sulfide. So, ta-da, that ends up with 17 grams as well. So you can see, even though we have different numbers here, we still obey the law of conservation of matter. Now the only other thing that can get a little more complicated is here we only had one product in this reaction. If you have 2 products, to show that you obeyed the law of conservation of matter, you would have to also solve for the other product. And to do that, since you already know what the limiting reagent is, you would just take that limiting reagent and convert it to the other product to include in your after reaction, so you know how much of the other product you have as well. So again, the more you label, the better, the easier it is, because we got a lot of math here, a lot of ratios. So label not only units but also substances, and that will be very beneficial to you. So make sure you're showing all of your work, and I will see you next time.